Let's have a look at the solution now to Logarithms challenge question number 1. So the first thing I'm going to look at is log base 3 of 4. So I'm going to write that as log base 3 of 4 equal to, and I'm just going to come up with a pronumeral m. I'm going to rearrange this. So somehow I'm going to express this log base 3 of 4 in terms of log base 10. Okay. So rewriting this expression or this equation in exponential form, we have 3 to the power of m is equal to 4. Now if we take the log of both sides, okay, so I'm just trying to save a bit of board space here, so log base 10, 3 to the power of m is equal to log base 10 of 4. Okay. So moving on to the next line, log law number 3 states that the m can move out to the front. So m times log base 10 of 3 is equal to log base 10 of 4. And we can divide both sides now by log base 10 of 3 and make m the subject of the formula. Okay, so m is equal to log base 10 of 4 over log base 10 of 3. Let's keep that aside. So now we have a value for m, which is really good. And in fact, the value for m represents log base 3 of 4. And we can substitute that now into the original expression. Okay. So log base 2 of log base 3 of 4 is really just log base 2 of m. And we're going to repeat the same thing again. This time I'm going to introduce another pronumeral. Okay. So I'm going to write that as log base 2 of m is equal to n this time. Now m I already have a value for. This I can enter into the calculator directly. I can get a decimal answer if I wanted to, but I'm going to keep it in exact form because that's what the challenge asks us to do. So now let's again express this equation in exponential form. Okay, so I'm going to turn the board over because I'm just about to run out of space. So 2 to the power of n is equal to m. Okay, so we have 2 to the power of n is equal to m. M we already have a value for. Let's rearrange this again and take the logarithm of both sides. Rearrange it so we can make n the subject of the formula. Okay, so log base 10, 2 to the n, 2 to the power of n is equal to log base 10 of m. Again, log law number 3, we can bring the n out to the front. Okay, so n times log base 10 of 2 is equal to log base 10 of m. Now, remember that m, we already found a value for that. Okay, so that's known now. N is unknown. So let's make n the subject. So n is equal to log base 10 of m divided by log base 10 of 2. Now I can substitute in the value for m. Okay, so n is equal to log base 10. Now, what was m? Do you remember? It was log base 10 of 4 divided by log base 10 of 3. Okay, divided by log base 10 of 2. I could have written it as a fraction. I could write it as all over log base 10 of 2. In fact, I could do that if I wanted to, but it wouldn't necessarily, it wouldn't change the answer and it would still be equally valid. Okay, so, and that is our exact form answer. So either way, whether you use division, the division notation, or use fractions, it's fine. Now, let's enter that into the calculator and see what we get. I might just see if I could get the exposure up on the, so you can see the camera screen. Sorry, you can see the calculator screen a little bit better there. Hopefully you can see that. Okay, all right, let's enter that in. Okay, so we have maybe fraction first, log base 10, fraction inside there. Okay, and we've got log base 10 of 4 over log base 10 of 3, close bracket, over log base 10 of 2. And you should find then that the answer is 0.333555 12925. Okay, 0.335512925. Sorry, just reduce the exposure a little bit there. Okay, and that's the solution to the challenge question. Okay, hopefully you got that. If not, it might be well worth reattempting this at some point and maybe checking it again. But it's a really good application of log law number 3. It's actually 2 applications of log law number 3.